For this part of section 13.3, we'll be doing more examples. For this function, f of xy equals 3xy squared minus 2y plus 5x squared y squared. I'd like you to find all partial derivatives and higher order partial derivatives for the function. Try this one now on your own, pause the video, come back and check your work. Okay, let's go ahead and do the partial derivative of the function with respect to x. You're going to treat x as a variable. So x is a variable here. The derivative of 3x is 3 times the constant y squared, 3y squared. Again, you're treating x as a variable and y as a constant. The derivative of minus 2y is 0. And the derivative of 5x squared is 10x times this constant. So it's going to be 10x y squared. Let's go ahead and find the partial derivative of this function with respect to y. You're going to treat y as the variable and treat x as a constant. Go ahead and draw a line in between there. When we take the derivative with respect to y, the derivative of y squared is 2y times this constant out in front. So that is going to be 6xy. The derivative of minus 2y is minus 2, and the derivative of 5x squared y squared is the derivative of y squared is 2y times this constant. So it's going to be plus 10x squared y. Now let's do the higher order partial derivatives. The partial derivative with respect to x and x again. Take the result of the first partial derivative with respect to x, treat x as a variable here, and treat everything else as a constant. The derivative of this constant is 0. The derivative of 10x is 10 times this constant y squared. So 10y squared is that higher order partial derivative with respect to x. And the higher order partial derivative with respect to y, you're treating y as a variable and treating x as a constant. The derivative of a constant times y is, the derivative of 6xy is 6x. The derivative of minus 2 is 0. The derivative of 10x squared y, the derivative of y is that constant, 10x squared. Now let's look at the mixed partial derivatives, the partial derivative with respect to x and then y. I'm going to go to the result up here. Take the derivative of this, treating y now as the variable and x as constant. The derivative of 3y squared is 6y, and the derivative of 10xy squared, derivative of y squared is 2y times 10x to get 20xy. Let's find the derivative here. The mixed partial derivative, f, y, and then x. Again, we're going back to this step here, the partial with respect to y, and then take the derivative of that with respect to x. We're treating x as a variable now and y as a constant. The derivative of 6 times x is 6 times this constant. We get 6y. Derivative of minus 2 is 0, and the derivative of 10x squared is 20x times y. Now, by the way, if this problem looks familiar, it is the same problem that was done in the PowerPoint example, but I just wanted to present this and show you my thought process as I work out the problem. Here's another example. Find the slopes in the x and y direction of the surface x squared plus y squared plus z squared equals 14 at the point 2, 1, 3. Hopefully you recognize that this surface is a sphere. X squared plus y squared plus z squared equals r squared, so the radius would be the square root of 14. And there's a point on the sphere, 2, 1, 3. To find the slope in the x and y direction, we need a function of just two variables. So we're going to solve this equation for z. If we subtract x squared and y squared from both sides of the equation, we get z squared equals 14 minus x squared minus y squared. To get the z by itself, we're going to take the square root of both sides. Now when you take the square root, you want to consider the positive and the negative. If the point here is 2, 1, 3, then we're looking at the upper half of the sphere. So it's the positive part of the square root of 14 minus x squared minus y squared. Okay, we can write this as 14 minus x squared minus y squared, that entire quantity, to the 1/2 power. So when we want to find the slope in the x and the y direction, we take the partial derivatives with respect to x and y, and we're going to be using the chain rule. Let's find the partial derivative of this function with respect to x. We can write it with z subscript x, or we can use those little partial derivative symbols. I'm telling you, my partial derivative symbols look like a number 2. So just know that that is not a number 2, it is the partial derivative symbol. So the partial derivative of z with respect to x, we're going to treat x as a variable and everything else as a constant. We are going to use the chain rule here. All of this to the 1/2 power is 1/2 of all of this. We're going to subtract 1 from the power. 1/2 minus 1 is a negative 1/2 times the derivative of what's inside. When we treat x as a variable, the derivative of these constants are 0, and the derivative of the negative x squared is negative 2x. This can be simplified to, since 1/2 of this, the 1/2 and the negative 2 will simplify to a negative x in the numerator. All divided by all this to the negative 1/2 power is the same thing as the square root of 14 minus x squared minus y squared. That's the partial derivative with respect to x. Let's go ahead and find the partial derivative with respect to y. And we can use those partial derivative symbols with respect to z, partial derivative of z with respect to y. And again, those look like the number 2 when I draw it, but it is the partial derivative symbol. Going back to here, we're going to take the derivative using the chain rule with respect to y. We'll treat y as a variable. So the derivative is 1/2 of 14 minus x squared minus y squared, all to the negative 1/2 power times the derivative of what's inside. The derivative of the constants are 0, and the derivative of minus y squared is negative 2y. You can simplify this, the 1/2 with the negative 2 and the y. You will simplify to negative y in the numerator over 14 minus x squared minus y squared, the square root of all that in the denominator. So to find the slopes in the x and the y direction, we're going to evaluate these partial derivatives at the point 2, 1, 3. So at the point 2, 1, 3, we're plugging in 2 for x and 1 for y. The partial derivative with respect to x will be a negative 2 divided by the square root of 14 minus 2 squared. 2 squared is 4, so that's 14 minus 4 is 10, minus 1 squared is 9, square root of 9 is 3. So the slope in the x direction is negative 2/3. And let's look at the slope in the y direction. If you're plugging in the point 213 in here, this is going to be a negative y, or negative 1, divided by 14 minus 2 squared minus 1 squared. The square root of 9 is 3. So the slope in the x direction is negative 2/3, and the slope in the y direction is negative 1/3.